Okay, let's jump right into this explainer. Today, we're tracking down something we like to call the invisible index killer. It's a massive diagnostic mystery in the Oracle database world. We're talking about a seemingly harmless coding habit, honestly, one that most developers wouldn't even think twice about, but it can trigger absolutely catastrophic performance degradation entirely behind the scenes.
You know the feeling. You spend hours, maybe days, meticulously tuning a query. You've built your B-tree indexes, you've gathered your statistics, partitioned the data perfectly. It should fly. But the second you hit execute, the database just ignores your beautifully crafted index and grinds to an absolute halt. It is incredibly frustrating. Well, we're going to uncover exactly why your supposed fast index might actually be a slow table scan in disguise.
So let's set the scene with some pretty high stakes. Picture this. It's Black Friday, e-commerce traffic is surging through the roof, and your perfectly indexed Oracle database suddenly starts experiencing severe lag during order searches. We're dealing with a massive 50 million row table here. You'd expect a lightning-fast index lookup, right? But instead, you look at the status and it shows a massive full table scan on the order ID column. The whole system is basically choking. Naturally, you dig into the application code to see what's going on, and you find a really simple search. But there is a huge catch. One query searches for order ID equals the actual number, 100501. The other query searches for that exact same value, but as a string wrapped in single quotes. Leaving off those two tiny little quotes is what we call the $20,000 typo. To human eyes, both queries look like they do the exact same thing, but to the database, they are literally worlds apart. The silent culprit here is a hidden database mechanism called implicit data type conversion. This happens when the Oracle Optimizer steps in and automatically transforms a column's data type to match a literal value of a different type during your query. Basically, Oracle's trying to be helpful. It's trying to make incompatible data types talk to each other. But ironically, this little bit of help completely ruins your performance. To understand why, you have to know that in the Oracle universe, data types have their own laws of physics. There's a really strict hierarchy. When you compare a number to a string, like a varchar2, the number always has higher precedence. It's considered heavier. So in any conflict between the two, the string has to surrender. It must be converted into a number. And because number always wins that battle, Oracle does something pretty wild internally. Without telling you, it forcefully wraps your perfectly indexed string column in a to_number function. So your nice simple query is secretly rewritten behind your back to say, where to_ of order ID equals the number. This kicks off a really disastrous chain reaction. Step 1, the optimizer spots the data type mismatch. Step 2, it enforces that strict number precedence rule. Step 3, it forces the column itself to be wrapped in that to_number function. And step 4, this is the fatal blow right here. By applying a function directly to the column, your B-tree index becomes completely unusable. Since the index was built on raw strings and not calculated numbers, the database has literally no choice but to abandon it entirely. If that sounds a bit abstract, just think of a scrambled phone book. An index is basically a perfectly alphabetized phone book, right? Well, applying that to_number function is exactly like trying to find someone's name in that phone book after somebody went in and scrambled all the alphabetical letters into numbers. You can't just flip to the S section for Smith anymore. The sorting logic changed on the fly, so you are forced to start at page 1 and read every single page in the entire book. And well, that is your full table scan. Okay, let's move from theory to some hard forensic evidence with a controlled lab test. We set up a 2 million row table where the user ID is a string. Then we ran 2 queries against it, an implicit approach, where we pass a raw number without any quotes, and an explicit approach, where we pass a string with single quotes to perfectly match the column type. The results are pretty eye-opening. When you look at the optimizer's internal plan, the difference is just stark. The implicit search defaults straight to a table access full, suppressing the index entirely. But the explicit search, using the exact same value but properly quoted, executes a flawless index range scan. The index is utilized exactly the way you intended.
So what does that actually mean for your database speed? Try a 10,000 times performance improvement. No joke. Just putting 2 tiny quotes around your string literal results in a massive optimization. By explicitly matching your data types, you are saving your database from executing literally millions of unnecessary function calls every single second.
This perfectly illustrates the raw speed difference. The implicit query, the one with no quotes, took 485 milliseconds to churn through the data. The explicitly quoted query, less than a single millisecond. To put that into database terms, the explicit search required just 3 consistent gets. It read 3 blocks of data. The implicit scan, over 12,400 blocks. It is a night and day difference. But wait, because there's a huge twist here, and this is why this issue is so incredibly dangerous. Implicit conversion is not just a silent performance killer, it's actually a critical runtime stability risk that is just waiting to blow up. We are literally talking about a ticking time bomb hiding inside your application code. Think about it. Oracle is trying to convert every single string in your column into a number. So what happens if even one rogue alphabetical character sneaks into that numeric-only string column? Say a user inputs 10A. The exact moment Oracle's TO_number function hits that A, it completely panics. It throws an ORA-01722, invalid number error, and your entire application query crashes instantly. Even if 99.9% of your data is perfectly numeric, one bad row triggers a massive system-wide exception. So, how do we disarm this landmine? The absolute best defense is adopting what we call the clean predicate rules. It's a super simple 3-step checklist. First, always ensure your host variable types exactly match your database columns. Second, if you absolutely must convert something, cast the literal value itself, never the indexed column. And third, start using static analysis tools during your code reviews to automatically catch these unquoted literals before they ever see a production environment. And if you stick to these simple rules, the return on investment is absolutely staggering. Cleaning up your SQL predicates can lead to an 85% reduction in CPU usage per query. You're completely eliminating the computational overhead of transforming millions of rows, which drastically reduces your I/O wait times and instantly improves your system's overall scalability. So I'm going to leave you with this question to think about as we wrap up today's explainer. Take a really hard look at your own codebases and your own execution plans. Are you letting the database guess your intent? Is there a single missing quote out there right now, silently suppressing your best indexes, doubling your cloud compute bill, and putting your entire system at risk of crashing today? Honestly, it might be time to go check.